Hello, my name is Rebecca Giuli, and I'm going to be talking about the Python library Matplotlib for CIS 4930. So to start, Matplotlib is a 2D plotting library for Python, and it can produce publication quality figures in a variety of hard copy formats and interactive environments. It's mainly used for math purposes such as portraying graphs using math data or with math equations or different algorithms. And it can be used in the Python script, within the Python and IPython shells, within Jupyter Notebook, and throughout many web application servers. So the goal of Matplotlib is to make easy things easy and hard things possible. As I mentioned before, it's used for a lot of mathematical graphing, and while those can be tedious to graph by hand, Matplotlib makes it easy for users who have very difficult math equations. And what can be generated: plots, histograms, power spectra, bar charts, error charts, scatter plots, and more. So this is an example of a bar chart / histogram, and here is an example of an error chart that can be created using Matplotlib. So pyplot is found through the matplotlib.pyplot method, and it is a module within Matplotlib, and it is the most common module. It is a collection of different command style functions, which is similar to MATLAB, which is another programming interface for using math. And each function within pyplot makes a change to a figure. For example, you can create the figure, you can plot lines, you can decorate with labels, and do a lot of other things. And throughout all of the function calls that you use for your figure, various states are preserved. So the current figure, the plotting area, and the plotting functions are all preserved as you're using pyplot. So we will create a basic graph with pyplot, and to use it, first you import matplotlib.pyplot, and here we have renamed that to plt. And the first function that you're going to use is plt.plot, and here we have it taking in two lists. Both have 1, 2, 3, 4, and the first list is a list of x-axis points followed by a list of y-axis points. So on our graph, we will hope to see points 1, 1, 2, 2, 3, 3, and 4, 4. And then our next function is plt.ylabel, and this takes in a string which is to be displayed as the label across the y-axis. And next we have the function plt.xlabel, and we have inputted the string. This is the x-axis, and we are hoping that this will be displayed as the label that goes across the x-axis. And lastly, we have plt.show, and this will display the graph that you have created. So this function will be running in a Python terminal of some sort, and once this program is run, the graph will be displayed in an outside window. So here is the graph that we have created. You can see that this is the y-axis is right here. This is the x-axis is displayed here. And we just have a basic straight blue line as our default. Next, we'll go into different plot formatting tools. So as we talked about before, the pyplot.plot function takes in a list of x-axis points, a list of y-axis points, and it does take in an optional format string. So as you can see with this first example, we did not put anything within the formatting string, so we got a defaulted blue line. But there are three components for this formatting string, which is the color, the marker, and the line. And all three are optional, and there are multiple choices for each. And so here we have shown the code for an example of adding this formatting. And here we have C dash dash, and this format string will indicate a cyan colored dashed line. So this is the example that we just saw in that code with the cyan colored dashed line. Other examples are if we were to put BO in the formatting string, it would be a blue circle, and M star would be a magenta star as the point. The next thing we're going to get into is how to print a picture with Matplotlib. So what you need for it is, again, the pyplot module, and you also need another module, cbook, matplotlib.cbook, which here we have renamed just to cbook. And what cbook is a collection of utility functions and classes to use within Matplotlib, and many were taken from the Python cookbook, which is where we get cbook from. So here are the functions that you need for printing an image. cbook.getSampleData takes in a file name, and as default, asFileObject equals true is the default for the return. So getSampleData will go into this npl.data/sampledata directory. It will get the data file that is specified here, which we have specified apple2.png, and then it will return a file object as in this example, or it could also return a file path. And here we have named this file object as image_file. The next function that we have is plt.imread, and it takes in this image file. And another input that could be taken besides the image file object could also be a file name or a URL. And what is returned is an array from numpy array that holds the shape of the picture. So this is going to be stored here in our image, which is really a numpy array that's holding the shape of this picture. More functions that are needed is pyplot.subplots, and how to use this is you will take in a figure and an axis, and it will create a figure and a set of subplots for the figure, and it will return the figure container, which we have as fig, and the axis object or array of axes, which we have as x. And this will depend on how many subplots were created. And something important to note is that Matplotlib can only read in PNG images. So if you have a PDF or if you have a JPEG, you will first need to convert it before you use this function. Next, we have pyplot.imshow, and in our code it was ax.imshow with the image. And the input is the image array that we have created by the previous imread function, and it will return a matplotlib.image object, and that image has been plotted on the graph. So this will show the graph here. The original picture was just of the apple, and it will add these axes along with it. And then something optional that we've decided to add is pyplot.axis with the parameter off. And there are different parameters for this that can change the display of the axis, and by us indicating that off, it means that the axis lines will be turned off for this picture that we can see at this bottom. Next, we're going to talk about interpolation. So Matplotlib is used to implement many mathematical processes easily, such as interpolation. And interpolation is a method of constructing new data points within a range of a discrete set of known data points. The pyplot library is also used when implementing interpolation. So how to implement? There are 18 different interpolation methods. Each vary in the range of the color and of the neighboring pixels. So here in the none interpolated graph, you can see that there are very discrete grid squares here, but when you get into the higher interpolation methods such as Hermite or Quadric, you can not even see the different grids here that we can see in none. And this goes along with how Matplotlib works to make hard things easy. Doing all of this manually would take a lot of work and a lot of time, and Matplotlib is able to quickly and easily show you graphs like this. So different functions needed to go through interpolation. We need random.rand, and it takes in an array with 5 columns and 8 rows, which we have here. And that is populated with different random samples. And the array is from the NumPy library, which we have imported. And then we use the subplots functions, which we have seen before, and is creating a figure with 1 row and 3 columns. And then lastly, we have here is this for loop for AX, interp, and zip. And this will create an interpolated graph for each method specified in this list. So we have the nearest, the bilinear, and the bicubic. And if we go back, we can say that nearest should look like this, bilinear should look like this, and last we had bicubic, which should look like this. And this for loop will perform for each loop, which is a different graph for each one. Next we have imshow, and imshow will display this interpolated image. And then we have set title, and set title, which we have in this example is the interpolation method capitalized. So as you can see on this graph, we have the different interpolation methods, which each are capitalized. And then lastly, we have ax.grid equals true. And this means that we will configure the grid lines of each image. So here you can see the different grid lines that we have created. And you can see in bicubic, it almost looks like a blur behind the grid lines. And here it's very clear. So lastly, we will talk about pie charts, which is another function within the pyplot module. And to create the pie chart is the function matplotlib.pyplot.py. And it takes in a list of values, which here we have as percents, and then there are many, many different default arguments that you can have as part of this function, and many different opportunities that you can have. So in this example, we have the different names, undergraduate, graduate, professor, and administration, the different percents, and we have our values of explosion. So here we will go through the different default arguments that we have used. So we have the explode, which is set to explode, which here we have none are exploded except last administration should be out of the chart a little bit. So we can see here that administration is in fact taken out of the chart. And then labels next is an optional string for specifying each wedge. Each label comes from the names object that we have specified here, which is undergraduate, administration, professor, and graduate. Next is auto percent, which is used to label wedges with a numeric value, and our labels have 1 decimal and a percent sign following, which we have specified here. We have 1 decimal and a percent sign. Shadow means that there is a shadow drawn beneath the chart here, which we can see. And lastly is star tangle equals 90, which means that we have rotated our graph 90 degrees. So if this wasn't set, then undergraduate would be either on the bottom or on the top as it has been rotated. So that concludes this PowerPoint, and we will go into other things to explore with Matplotlib. So first we can explore the bar chart here, which will take you to the Matplotlib bar chart website, which explains how to use a bar chart. And then next we have barcodes, which will explain how to create your own barcode. And then after that, we have histograms, which will take you to create your own histogram, as we saw an example in an example picture in the very beginning of this. And then after histograms, we have linked auto-wrapping text. And we can see that this is really interesting. It doesn't really fit in the graph, but this is the point of auto-wrapping text, is that you can do this effect on it. And then lastly, we have plotting 2D data on a 3D plot. And as you can see here, we have lines and different points that are all in this 3D plot. And all of these links will be in the description. And here are the references, and thank you.